So for this next example, this is very similar to the ones that we've previously done, but the only reason I'm going through very similar examples is because I want students to get a bit deeper understanding of this concept right here, which is roots of complex numbers. So we'll get straight into it. It says, given z to the power of 5 plus 1 equals to 0, A, done this plenty of times, find roots of the equation. Very straightforward. B, factorize the product of linear and quadratic factors. Little bit different, but won't be that bad. And then C is just hence find cos pi upon 5 plus cos 3 pi upon 5, which is straightforward as well. So we'll start with A, find roots of the equation. We already know what to do here. A, z to the power of 5 plus 1 equals to 0. This time they've given us an equation. So this can also be written as z to the power of 5 equals to negative 1. Bring the 1 on the other side. De Mor's theorem right here. Cis 5 theta, r in this case will just be 1, equals to negative 1. How can we rewrite this in terms of cis theta right here? So we've got a little note to ourselves. Negative 1 equals to cis 2k plus 1 pi. We're going to remember that. 2k plus 1 pi. Put that in right here. We'll go cis 2k plus 1 pi. Perfect. Cancel out the cis. 5 theta equals to 2k plus 1 pi. Correct? Theta then equals to 2k plus 1 pi all upon 5. We know what the argument is, theta is. Now we do come to the principal argument right here to know the limits. We've got for k, the limits for k, the values of k that are visible. Negative pi less than, sub this in over here, 2k plus 1 pi upon 5 less than or equal to pi. Less than or equal to pi. Multiply both sides by 5 and divide by pi, we get negative 5 less than 2k plus 1 less than or equal to 5. Minus both sides by 1 and divide by 2. So minus 5 minus 1 minus 6 upon 2 is negative 3. Less than k, less than or equal to 5 minus 1, 4 divided by 2 is just 2. So we know that the values for k lie between negative 3 and 2. Sub these in for k. First solution, I'll write it over here. Z1, complex number. Can't equal negative 3, we add negative 2 to this right here. Or in this case this. 2 times negative 2 is negative 4 plus 1, negative 3. So the first solution we have is cis negative 3 pi on 5. First solution. Same thing for the second solution. Instead of negative 2, we go negative 1. Negative 1 times 2 is negative 2, plus 1 is negative 1. Negative 1, minus 1 pi, which is just negative pi upon 5. Cis minus pi on 5. Second solution done. Third solution, Z3, we can add, in this case 0, because negative 2 negative 0, this time we becomes cis pi on 5. Z4, add 1, we get 3 pi on 5. Cis 3 pi on 5, and then the last one, we get cis pi, 5 pi on 5, 5 cancel out, pi, which is just negative 1. So we can see a trend here going. We've got conjugate pairs. So we rewrite these solutions as their conjugate pairs. Just over here, let me rub this out quickly. So we've got, boom, we can go cis pi on 5, cis negative pi on 5. cis 3.5, cis minus 3.5, and then the last one is just -1. So these are your 5 solutions for A. Go on to B. We need these, so I'll just leave these over here, rub these out, and do B at the bottom right here. So we need this, we need these for B. B, right here. Factorize as a product of linear and quadratic factors. We'll start with linear factors. Z to the power of 5 plus 1 equals to Z plus 1. First factor, this. Z minus cis pi on 5. Z minus cis pi on 5, little bar at the top, just so we know that's the conjugate of this. Same thing, Z minus cis 3 pi on 5, I'll just rewrite this at the bottom here, Z minus cis 3 pi on 5, but little bar at top, and then -1 right here. Now for the quadratic factors, we'll go at the bottom. We go Z plus 1, obviously, it's always there. Now we just expand these brackets. So Z squared minus, we get 2 cos pi on 5, correct? Yep. Plus, we get 1. And then, same thing, Z squared minus 2 cos 3 pi on 5. Sorry, 3.5 plus 1. So these are your quadratic factors of this over here. We'll go down to C. I'll just do C just over here, just make it easier. This is just because we've got the roots right here, correct? We can just go sum of roots in polynomials, sum of roots in polynomials. So we go in this case, let's come back to this. Alpha, beta, gamma, delta, and then the fifth root equals to minus b upon a. When we add the sum of the roots, we go minus b upon a. In this case, minus b. b is just 0, so that just equals to 0. So all of these added together should equal to 0. Let's come back. We can do cis pi on 5 plus cis minus pi on 5 plus cis 3 pi on 5 plus cis minus 3 pi on 5, correct? Minus 1 equals to 0. Next step, put these to 1. This then becomes, add 1 to both sides, we have, and then we've got the conjugates. So cos pi on 5 plus I sine pi on 5 plus cos pi on 5 minus I sine pi on 5. So that then only gives me real values. So we then have 2 cos pi on 5. Same thing for here. I'll just quickly explain what I mean by that. We can expand this. Cos pi on 5 plus I sine pi on 5. Conjugate at the bottom. Cos pi on 5 minus I sine pi on 5. When we add these two together, that and that cancel out, and which leaves me 2 cos 5, or 2 cos pi on 5, same thing over here, plus 2 cos 3 pi on 5 equals to 1. Divide both sides by 2, we then have cos pi on 5 plus I sine pi on 5 equals to 1 upon 2. So that is how you do C. And the rest of the questions right here.